Recall the definition of sequence. So what was sequence in one line? Any one of you can assist?
What, ma'am?
What was sequence in one line? If I want you to describe sequence in one line, what is in your mind about sequence? How will you describe sequence in one line?
An item is a collection of elements.
As a domain of natural numbers to real numbers.
Yes. Sequence is basically a function from natural number to real number. So you know very well what a function is. Sequence is basically a particular case of function where the domain is particularly the set of all natural number. Okay. So this is sequence. And now you know the concept of limit of a sequence, right? Right? I think do I need to explain it again, or you know already? I think you already know, right? And so limit of a sequence is basically the number L such that the sequence n tends to the number L as n tends to infinity. This is basically the limit of a sequence. And if L is a finite number, then this sequence we will call this sequence to be a convergent sequence, right? Otherwise divergent, right?
Can I ask a question?
Yeah,
Yes,
this concepts you already know, है ना? So you can solve some problem over it, right? So this is one example for a sequence. Suppose an equals to some 10 n power 4 plus n cube plus 1 by 20 n power 5 plus 4 n square plus 7. Suppose this is a sequence. Okay. Now what you have to do, you have to find the limit of the sequence. What is the limit of the sequence? It's a pretty simple question. So you have to find the limit of the sequence. What will be the limit?
zero. Is it n power 5?
Yeah. N power 5. 10 into n power 4 plus n cube plus 1 over 20 n power 5, 4 into n square plus 7.
Zero. Yeah, it's zero.
Zero.
Okay, so 0. So many of you are saying it's 0. I have one answer 1 by 20. So any other answer? Do you have any other answer?
Zero.
Okay. So let us solve it. Okay. So what we have to do basically, limit n tends to infinity n, right? This limit we have to evaluate. So is 10 n power 4 plus n cube plus 1, 20 n power 5 plus 4 n square plus 7. So what should be the next step according to you?
And take n to the power 4 common from numerator and n to the power 5 common from denominator.
Yes. Yes. So then we will get something like that, right? Twenty plus 4 by n cube plus 7 by n power 5, right? We can take n power 5 common from both the portion and then we can cancel it out. So now n tends to infinity, that means 1 by n tends to 0, right? So this portion will be tending to 0 and this portion will be tending to 20, right? So it is 0 over 20, hence it is 0. Fine?
Yeah.
Yeah. So I think you don't have any doubt with this. So we can move on with our...
I have one small doubt. Can I ask you now?
Sure, sure.
If this function was defined piecewise, even number one, odd number another series.
Okay.
If both,
Do you have anything, any example in your mind?
no, I mean we can just take, if it is odd, an is a function which converges to L1. If it is even, it converges to L2.
Okay. And
Now,
convert to L2 if n is even.
yes.
Oh. Mhm.
Now, what we will talk about the function converges to. Basically, the subseries converges to different
Yes.
limits.
So if
As a original series, mother series, where does it converge to?
So the thing is, for this we have a result. If we have a sequence n and we have some subsequence a n r and some a n k, just suppose, such that union of these two set equals to this whole set.
Okay. And even they are disjoint, assuming they are in this case it is disjoint.
They may be disjoint, but union is the whole sequence again. Okay. Then we have a result that this an will converges to some L if and only if all the subsequences converges to the same number L.
If
Okay.
they are different, like this case which I
If they are different, then the sequence is not convergent. It's maybe like divergent, maybe oscillatory. So better to
okay. That's all I want. Thank you.
yeah. So in this
But
case,
Hello,
also,
ma'am. In this case, if n tends to infinity and then an goes to L, then automatically then even part and odd part, everything will go to L. Na?
no, if both
no.
subsets goes to the same, then it converges. Otherwise, we
This
don't
means
know.
this line means we have a sequence n, and for that we have two subsequences. Hai na?
Yes,
One is a to n and one is a to n minus 1.
correct.
That means we are taking one subsequence with only the even terms and another subsequence with only the odd terms.
Correct.
And this is tending to some L1, this is tending to some L2. But if L1 and L2 is not equal, in that case, it will imply that A in this sequence will be not convergent. Okay.
Thank you.
Yeah. From this result, you can note it down. Okay. So any other doubt up to that?
Can you please explain it once more?
Which one?
Same thing.
Okay. So it's basically, for example, if we have a sequence n, for that we can take some subsequences, right? Suppose we are taking two subsequences, a to n and a to n minus 1. Okay. That means these two are subsequence of this sequence n, and if we do union of these two sets, then it will be again the set n, right? Because here we have a1, a2, and so on. This sequence means we have a2, a4, and so on. Here we have a1, a3, and so on, right? So if we do union of these two sets,
Yes.
this one and this one, it will become this set again, है ना?
Yes, okay.
So for this type of case, if an tends to some L, if and only if a2n tends to L and a2n minus 1 tends to that L. Okay.
Okay.
So if n is convergent to some limit, then all the subsequence should be converges to the same limit. Okay.
Yes,
Does that?
ma'am.
Similarly, we can again do this thing. So this is a in general result. You can follow this. In this case,
Is there a theorem on this?
yeah, this is a result. Yeah, this is a result.
Is there any textbook where I can read more about this?
There is a basic textbook. It's Real Analysis by S.K. Mappa. You can check this book for this.
SK?
S.K. Mappa.
Could somebody put that in the chat? I can probably see.
S.K. Mappa. M-A-P-A. S.K. Mappa.
SK.
Otherwise, there is one other book, same Introduction to Real Analysis by Bartley and Saubert.
Bartley, yeah, but the real analysis, that's this
Real
aspect
Analysis
was
by
not.
Bartley and Saubert.
That I
So,
see.
very basic portion they covered about sequence and series. You can go through this.
I'll read Marpa. Let me see. Thank you.
Okay. So, if you don't have any further doubt, we can move to the next example. Suppose we have a sequence AN,
Excuse me.
which is
Can you please explain the convergence and divergence graphically? How we do it?
okay. So it's basically, suppose this is the axis for our n, and when n tends to infinity, this is suppose our sequence. This is suppose a natural number set. Okay. So when n tends to infinity, the graph will be tending to some real number. This is a real number system. This is some real number L. Okay. This is basically a graphic. If you can draw the limit for a function, right?
Yes, ma'am. We find the limit, but I don't know about the convergence and divergence.
Yeah, convergence is basically the same thing. Limit is for arbitrary function, and convergence, we are defining this term. Convergence is basically a particular case for limit, which is for the sequence. Here we are taking the domain as natural number, nothing more than that. Okay. And here we are taking n tending to infinity, a particular case. And the graph will be same as the limit. Fine?
Okay.
So suppose we have a sequence a into n equals to 1 to m, some n square root over 6 m power 6 plus 100, where this a is some natural number. So what will be the limit of this sequence? Take your time to solve it and write your answer on the chat box. We have to find the limit of the sequence. That means we have to find the limit, basically limit a tending to m tending to infinity am. We have to find the limiting value of this function. So one hint I can give you, try to expand is, and like if you have some formula for this, try to apply it and try to cancel out this term.
Is A a constant?
Yeah, A belongs to natural number. Two by root 6. One answer we have 2 by root 6. Any other? A by root 6. Okay. So you can start solving this. As I said, we can expand this. If we expand this term, it will be 1 plus 2 square plus dot 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 m square, right?
Yes, ma'am.
By 6m power 6 plus 100. So this a is a constant and it's not dependent on the term m. So we can take this outside the limit, right?
Yes.
And for this term, we have a formula, right?
Yes, ma'am.
M into m plus 1 into 2m plus 1 by 6. Am I right?
Yes, ma'am.
Yeah. And from this term, we can take m power 6 outside the square root, right? This will be m cube. And this term will be 6 plus 100
Ma'am,
by
why 6 is there? Yeah, that is okay.
Fine. So what will be the next move?
Ma'am, please repeat
100 by
previous step.
Mhm.
That would be 100 by m power 6 inside the square root.
Yeah. It was m power 6 inside the square root. Okay, sorry. Yeah. So we can take m power 6 as common. Then it will be m cube outside the square root, right?
Yeah.
Yes.
Yes, ma'am.
So now we can rewrite this term as 2 plus 1 by m by 6 into square root 6 plus 100 by m power 6, right? Any problem with this step?
Ma'am, can you please
So that
explain this step, the one that you've written right
which one?
now? The recent step only, the last step.
This one.
Yes.
We're taking mq from this factor, and then we are canceling this and this term out. Okay.
So, okay.
Now we can put m tending to infinity directly. So there is no other problem, right? So it will be 1 into 2 and there will be 6 into root 6. So this is 3. It will be a by 3 square root 6. Okay. So any doubt regarding the solution? Could you please explain how is it 6m cube plus 3? Yes. Yeah,
M
so we
comma
have
out.
this formula. Let me say this is equals to basically m into m plus 1 into 2m plus 1 by 6. This is one formula. Okay. We wrote this formula here and then we take mq from this factor. Fine.
Yes.
Yeah. So any other doubt? Now,
ma'am.
if you, yes.
No, ma'am, no doubts.
Okay. So now if you have any other doubt with the sequencing, like sequential concept, or you have some problem in your mind, you can put it in the chat box. We can solve it now.
Oh,
If
ma'am, can you solve the example for finding the limit of the 4an sequence? It is in the mock quiz.
okay, you just share you can share the screenshot here in the chat box.
Yes, ma'am. Can you please wait a minute? It will take a little time, so it will be okay.
Okay. You can share. Otherwise, if you have any other question related to sequence, you can ask it. Then we will move to limiting concept for like not in general function, limit continuity and differentiability concept. If you have,
Ma'am,
yes,
I have a doubt. Do you want me to post it in the chat box or tell you verbally?
it is better if you can post it in the chat box. But what is your doubt? You can also ask me.
Ma'am, there was a question, like I was able to do it. I just want some clarity for it. There was a question which said there's a sequence which is an is equals to 1 by n.
N equals to 1 by n.
Yeah, and then we have to select the subsequences for it. The option that was given was an is equals to 1 by n square.
1 by n square. Okay.
B, and the second option was bn is equal to 0.
Okay.
And Cn, the third option was given as Cn is equals to 1 minus 1 by n.
1 minus 1 by n.
1 by n.
Any other option?
No, ma'am. Only these three.
Okay. So it's clearly it's a subsequence,
Yeah, this I was able to do.
right? Because if n is some natural number, then obviously n square is a natural number. So this is a subsequence. This is a constant sequence with the term 0, right?
Yes, ma'am.
But is it the case 0 belongs to this sequence?
Oh,
Ma'am, the
Is there any
explanation.
natural number? Is there any natural number such that 1 by n equals to 0?
no.
No. It will tend to 0, but it will never be
Yes.
equal. Yeah.
Yes. So this will tend to 0, but it will never be equal. So 0 basically doesn't belongs to the set, right? So this set, we cannot imply that this is a subset of this sequence, right? So this is not a subsequence. Fine.
Yes, ma'am.
What about this term? Is this term belongs to this? Can you find any counter example or else?
C1 is 0. C1 is 0, which is not an element in AN.
C1 is
0,
right.
which is not in AN.
Yes, very good. So again, with the same logic, this is not a subsequence. Fine.
Or we could think it like I want to ask my explanation is right or wrong. For an, as n increases, the sequence of the question I'm saying, the equation an is used to 1 by n. As n increases, the equation becomes smaller and smaller, right?
Yes.
And for Cn, this will range between 0 and 1, right?
Yes.
So it can't be a subsequence of an.
Yeah.
Okay. Understood, ma'am. Thank you, ma'am.
That well put.
Ma'am, I posted the question in chat box.
Okay. So there are so many questions. Yeah, this limit of the sequence 4n. So was there anything about the sequence an? Limit of the sequence an?
Yes, ma'am, I also posted. Please scroll it down. You can see it.
Okay, so an equals to this. Okay. So we have an equals to 3n minus odd and y 7 plus n.
This is a mock test.
Okay.
Yes, it's the question from mock for question.
Okay, so what is the limit of n? Are you able to find the limit of n? Here,
Yes, ma'am, I tried,
clearly we
but
can
it is
define two
confusing.
subsequence. Here we can clearly define two subsequence, right? One is for odd number, which is a 2n minus 1, and
Both,
one is for even number, which
both
is
converges to 5 by 2.
both converges to 5 by 2, right?
Yeah.
So this sequence will again converges to 5 by 2 because these limits are same, and their union is again n. Okay. So 4n will be converges to 4 into 5 by 2, which is 10. Okay. It's fine.
So, ma'am, if we have to find the for infinity the limit, then we can solve either the odd one or the even, or we have to
Yeah.
solve both and check
If
it.
you have some sequence in this pattern, then you can solve for odd one and even one. If the limit is same, then the sequence will be convergent and converges to that limit. And if the limit is not same, in case the sequence will be not convergent. Okay.
But ma'am, if a question is like this, that they have asked for an, then it shows that this function is a convergent. So we should find both, or one would be enough.
They made sure it converges.
Yeah. If
Because
they
they
make
made
convergent,
sure it is 5 by 2.
then, yeah. This is basically a mind game. You can check this one. Because in this 13th question, they asked you to find the limit of the sequence, then maybe it is a convergent sequence. But always better to check for the both if it is not mentioned in the question that the sequence is convergent. Okay.
Ma'am, how is it 5
Yes,
by
ma'am.
2?
Okay, that you can check.
Taking
Right?
common n square from both denominator and numerator in the even part.
It's for the first time I'm asking, for the first one.
Okay, first
Yeah.
one, the floor function is, since it is odd, it will be
We can divide by n.
n
minus 1 by 2.
odd will be always 2n minus 1.
Yes. This n is odd. That means it is something like 2n minus 1. Some
n by 2.
yeah. So if we divide it by 2,
It will be n by 2.
yeah, it will be n minus
N minus 1 by 2.
by 2. So if we take this function, it will be n, right?
Yeah,
Yes.
yes.
Options in the 12th question, I think.
Could you explain this again? Just this part.
Which one?
You
This
find
sort of
an expression for floor function in terms of number.
Yeah, in terms of odd and even.
Yeah, then you will figure it out. I think there is a question just below that.
Yeah, 12th question.
Yeah,
That is above that.
yeah, whatever the right choice that we will apply here, it will be okay.
Yeah.
Yeah, it's
For odd,
n minus
it's
1.
minus 1 by 2.
Indirectly, they give a
Can
hint.
use that.
Basically,
I think
indirectly,
since-
they give a hint.
Yes.
Since everybody's speaking, it's really difficult to understand what ma'am is trying to explain. Can we just
Yeah,
let
I
her
want to
explain?
listen to you one by one. Please speak one by one so that I can listen to you. Is there anything to say?
You carry on.
Okay. So if n is odd, then n is one of the form like that, right? So if we take this by 2, it will be something like that. That means we are taking some natural number, then you're just subtracting half, 0.5 from this. So it will be some natural number minus 0.5. That means 0.5, something like that, right? I got it?
Yes,
Am I
ma'am.
correct?
You're right, but then somebody has to work it out detailed.
It's fine. We need to
Sometimes
sometime we have to check it in detail, right?
We'll be discussing the mock tomorrow morning. It's all right. I just want an idea as to how it happened.
Okay. So it is 2n plus 1, 7 plus 1. So it will be 2 plus 7 plus.
it will be 5. It will be 5n plus something.
Why it's
So 2n minus 1 divided by 2.
So use n minus 1
Gets
divided by 2.
normalized. It comes like that.
mm-hmm.
See, the floor function will be replaced by
Yes, n minus 1 by
n
2.
divided by 2. So when you rationalize it, 6n minus 1 n becomes 5n. In the denominator, you will get a 2. So it works out to be 5 by 2.
How? Like I'm not getting it.
Ma'am, we have to replace n by 2 with the n minus 1 by 2. That's
Yes.
all.
Yeah, she's correct.
Okay.
N minus 1 whole divided by 2.
Okay.
Yeah, that's right. Something
It
like
will be n minus 1 whole divided by 2, right?
Yes, ma'am. Perfect.
Okay, then we can adjust it. Then it will tend to something 5 by 2, right? Right?
That's correct. That's correct. That's correct.
Yeah.
Ma'am, from where you came that n minus 1?
Ma'am, can you please explain
I'm
this?
still
Because
not
it's
able to
confusing
understand how
now.
it's by 5 by 2.
Okay, you can then simplify this, no? There are so right.
Ma'am,
Then it
how is this n minus 1?
1 minute. By it is because here we can find n minus 1.5. That means from here we can do this, right? Right?
What,
Yes,
ma'am?
ma'am.
Please explain it again. Not able to understand from where you got that n minus 1.
Greatest integer smaller than that value. So if you want an integer, then both would have the same denominator, right?
N is what? Can you repeat it?
No, I was explaining why it is n minus 1 by 2.
Okay.
Hello, ma'am.
Mm-hmm.
Ma'am, it would be 2n minus 1, no? Because n is given odd. So for n equals to
Yeah.
odd, in natural number is 2n minus 1. So it's also 2 will come with n.
We divided it by 2, right?
No, it's not like that. It's like the n in that floor function will be replaced with the n representing the odd numbers. Odd numbers are of form 2n minus 1. So it will be 2n minus 1 upon 2 in place of floor function of n by 2. After that, when you will go to open the bracket and simplify, then the 5 by 2 will come.
Let's use the options in the 12th question. It will give the perfect answer.
No, okay, let me check it.
Wait a
I-
minute.
Ma'am, is floor
Can I-
of n by 2 always odd, ma'am?
Can I explain?
Yeah, sure. I'm
Okay,
also getting
let's
confused.
take n by 2 will be either a full digit or it will have a 0.5.
Depends upon the values of n.
Will be
Now,
always
wait,
something 0.5.
n by 2 for a natural number n, it will be either full integer or it will be full integer plus
half
half.
integer.
Correct?
Yeah.
If n is 3, it is 1.5. If n is
Correct.
5, it is 2.5. N is
2.5.
3. These are the only two options.
Yes.
Flooring takes the lower limit. So if n is 6, it is 3.
How you have taken n is 6 if n is odd?
Odd. N is odd.
We can again
n
take
is
some
odd and you are
examples.
taking n as 6.
So if it is odd, it will be always having a 0.5.
It will always be
So
0.5.
we should minus
So the
1.
simplest way is subtract 1 from the n and divide by
Yeah.
Yes.
Correct.
the floor of n by 2 is equal to n minus 1 by 2. That's it.
When n is odd.
Odd, because that's the whole
Okay. For better understanding, what we can do, we can take some example, right?
Yeah.
Suppose we're taking some n equals to 3.
Hmm.
Then what will be n by 2? It's 1.5, right?
Yeah.
So if we take the box function, it will be 1, right?
1.
Yeah.
So now if we take 2, which is n
No,
minus 1,
Yeah.
and if we take 2 by 2, which is n
One.
minus 1 by 2, it is 1,
Same
right?
result.
So box function is
Hence proved.
1.
It fits for all.
Right?
Take 7, it will work out.
Yes, I'm now understood what is meant.
Similarly, we can do the argument for all the for even an odd number, okay? Okay?
Yes, ma'am.
Only for odd.
Yes, ma'am.
This is only for odd definition.
Okay, but
Ma'am, so it was if it
Mhm.
was ceiling function, then it would have turned to n. Like n minus 1 by 2 would have turned to n if it was a ceiling function.
So
minus
it would be greater than this, right?
Yeah, so it
If
would
it is
be
a
n,
floor
right?
function, it is later than this, and otherwise it will be greater than this. Yes. Yes.
Yashvi, just look at it. N
Then
by
it will be n plus 1, because we want some even number to evaluate this value. Okay.
So we'll do n plus 1 by 2.
Yes.
Okay, got it.
So if we have this again 3, so the floor function of 3 by 2 will be 2, right?
1.
Sorry, not floor.
1 by 2 is 1.
1.
Not floor function. Sorry.
Ceiling function.
Ceiling function. Yes.
Ceiling function.
Yeah. It will be 2, right?
ceiling you could add.
Right?
Yeah.
Yes, ma'am.
2. So if we do n plus 1, it will be 4 by 2 means it will be 4 by 2. It will be again then 2. Right?
Correct.
This will not work. So it's clear now?
Yes, ma'am. Now it's clear.
Okay. Okay. So we can now move to the limiting concept, limit, continuity, and differentiability.
Ma'am, there was a question in activity 3 in week 8. Could you please explain that? I put it in chat.
Yeah, is this in the chat? Is this question in the chat? Okay.
I just put it in the chat.
This one, if x plus y equals to fx fy. This one.
Yeah, ma'am.
Okay, so this is a question involving the derivative, I think. So we can do this this derivative related question after this. Okay.
Yeah, sure.
Yeah. So limit again. Suppose we have a function, then if there exists some L such that which is a finite real number, such that at x equals to a we have limit extending to a, this f of x equals to L, then we will say this is limit of the function, right? And if particularly this L equals to f of a, then we will say this function is continuous at a, right? It was the definition for limit and continuity. And for differentiability, what we know, if we have this limit a plus h minus f of a by h, if this exists finitely, then f is differentiable at x equals to a, right?
Yes, ma'am.
Yes, ma'am.
Yeah. And we will denote this limit as f dash a, right?
Yes,
We will
ma'am.
call
Yes,
this
ma'am.
as the derivative of
Perfect.
f at a, right?
Yes, ma'am.
Or else, what is the another name?
Slope.
Yeah, slope of f. Slope of f at the point x equals to a, right? And another
Yes,
one,
ma'am.
we know equation of tangent is basically y equals to at x equals to a is f dash a into x minus a plus, it was plus I think, no? F of it.
F of a.
Yeah. So it was the equation of tangent of the function f at the point a, right? And
Yes, ma'am.
then, yeah, you know about L'Hospital rule. If we have some form like that, infinity by infinity or minus infinity by infinity plus minus infinity, then we will apply, and what L'Hospital rule says that limit extends to a if x by gx equals to limit extends to a f dash x by g dash x, right? So this was the quick summary of week 8. So this we already know, right? So based on this, we will solve some problem.
Ma'am, your screen.
Yeah. Let me.
I had a just simple question to ask.
Mm-hmm.
Is linear approximations equation and tangent equation same,
Yes.
or are they considered as same?
They
Yes, ma'am.
consider the same actually. Yeah.
They are same.
They are same. Yeah.
Yes, ma'am.
Are you able to see my screen?
Yes, ma'am.
Yeah. So
We
they are
use
same basically at this point.
No, we use tangent to approximate linearly.
Yeah.
Okay.
So at this
Thank you.
point, they are basically same. Okay.
Yes.
Like at this point, near to this point. Okay. So I have example. Suppose you have a function x. So can any one of you say, is this function differentiable or not?
Yes, ma'am, it is
Yes, ma'am.
differentiable.
It is.
Differentiable.
Yes, ma'am, differentiable.
Okay. So what is the reason? How could you say that it's differentiable?
Is it x
There's
sin
no
x?
sharp edges on the graph.
Is it x sin x?
Yes.
Yeah. X sines.
So what we know that if
Differentiable
you have
function.
two differentiable function, then multiplication of two differentiable function is again a differentiable function, right? So the sin x function, we know this is something like that. So this is a differentiable function, and x it's a same. So individually these two functions are differentiable, right? So multiplication of two differentiable function is differentiable, right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So suppose we have a function L such that at x equals to a, we have L of a equals to f of a, okay? And the slope of L is f dash a at the point a. Then now what will be the equation of L?
It will be the tangent at slope, same as the slope part f dash of a.
I just gave the definition, right? Slope and tangent.
Yes, ma'am.
Yes, ma'am.
So yeah.
Ma'am, could you scroll up once?
Mm-hmm.
This is y is equal to f dash of a. That equation is also for linear approximation, right?
Yeah, this is equation for tangent. So yeah.
What is the difference? Like I have this basic difference. What is the difference between this equation of tangent and linear approximation? Because both the equations are same.
Yeah, both the equations are same, because at this point the linear approximation is the tangent is basically same as the linear approximation at this point.
So it's the same at some
Yeah,
specific
yeah.
point. That is
At
the
some specific point, this is same.
sorry.
Yeah, at this specific point, this is same basically, nothing else.
So at some specific point, this is the linear approximation. Otherwise, it's the equation of tangent, right?
No, it's equation of tangent and it's linear approximation of the function.
Okay, both.
Equation of tangent can be used to
Yeah, it's the
approximate
equation
some
of
value.
the tangent at the point x equals to a, right?
Sorry?
If this is the point, then this is the tangent at the point a, right? So this is the equation of the tangent of the point a for this function. Also, this is the linear approximation of the function at this point, near this point.
Okay.
This is basically same, okay?
Ma'am, also one more doubt. This L hospital rule, does this also apply when it is 1 by 0 form? Like when it is 1 by, so 1 by 0 is not defined, right?
No.
So,
no, in that case, the limit will not exist.
it will not exist. I had
This
this
is
doubt because in
not the
Solve With
case.
Us, there was one question where we had to find where L hospital rule is applicable. And it gave me a wrong answer when I put 1 by 0.
Yeah. Because
1 by
1
x.
by 0 is not the case for L'Hopital rule, okay?
Okay.
So these are the particular case. Also 0 infinity by 0, 0 by infinity. So,
Okay.
okay, so it's fine now?
Yes, ma'am.
It's fine now? Yeah. So then we can solve this problem.
Y equal to L of A plus L into yeah, x minus A.
L
F dash
into?
of A. I mean, L is F dash
Yeah.
of A. Sorry, L is the slope at the point A.
L dash A, right?
I mean,
L
F
dash
dash
A,
A.
right? Yeah.
Yeah.
This is the tangent, or
Yeah,
yeah,
equation of
this is the
tangent.
tangent for L that we have. So we can use this one, right? This y means actually L of x, right?
Yeah, that's one.
Yeah. So it's done, actually nothing to do. So L of x, now we have this line, so we can put here. Again, the slope is same as this. That means it is
F dash.
Now what is f dash a?
Slope of the function at A.
Yeah. So what is the equation? F dash x equals to
sin x plus x cos x.
sin x plus x cos x, right? So it is basically sin a plus a cos a, right? Into x minus a, right?
Yes, ma'am.
So we can simplify it, then it will be x plus x minus a into sin a plus a into x minus a cos a, right? A will be cancelled out, then it will be sin a plus a into x minus a cos a, right?
Yes.
Okay, so this is the function L. Any doubt with this?
No, mom.
Okay. Okay, so we can move to the next example. So here we have a mod function. Now you have to comment for the limit, continuity, and differentiability of this function at x equals to a. At x equals to 8, does limit exist for this function? Is this continuous and is it differentiable?
It is continuous but not differentiable at 8.
At 8.
Yeah, at 8 it is not differentiable, but it is continuous.
Okay. So basically, it's clear from the mod function, right?
Mom, is it plus 20 in the end?
Mm-hmm. Yes?
Is it plus 20 in the end?
Yeah. This is plus 20 only. So it's fine. We don't have any problem with this any other term because they are simply a polynomial function. Only we have problem with this term, right? Right?
Yes. Yes.
Okay. So if you have no problem with this, then we can move to the next question.
One doubt now.
Huh? Yes.
This before the mod of x minus 8 happen the differentiability at x. No?
Can you repeat it?
Does the x present before the mod function affects the differentiability at x sum x equal to 8?
No, because again, it will take positive and negative side in around 8, right? Right? So again, we can solve the problem, right? So how will, if we expand the function, it will be (20) when x greater or equals to 8, and x cube minus x minus 8 plus 20 when x less equals to 8, right?
It's not this function in the Desmos. There is no sharp points at x equal to 8 now. So only I'm asking.
Okay, so we can check it. So this if we break the function simply, this is the function, right?
Yes, ma'am.
Okay. So what will be the left hand limit and right hand limit? If we take x tends to 8 from the negative side, then which function, which one I have to take? This one, right?
Yes, ma'am. The below
The
one.
second equation.
This is minus x squared plus 8x plus 20, right?
Yes, ma'am.
Yes, ma'am.
So we can put directly 8 here. So this is 8 cube, 8 squared plus, again 8 squared plus 20. Right?
Yes, ma'am.
8 will be cancel out. And this
You are checking for continuity.
It will be
Continuity is all right.
8x, right?
no, we're checking for limit.
Limit will give you the continuity. It is continuous at 8.
Yes. So limit.
The slope changes. The slope changes.
Yes, obviously.
That is why it is not differentiable.
We are checking for the limit. We're doing the limit. Yes, yes.
532.
Ma'am, it will be minus 8x, right?
Which one? No,
Minus 8x.
minus will be cancel out and it will be plus, right?
Ma'am, if
Yes.
x is lesser than 8, then it will be minus x. If we take minus as common, it will be 8 plus x, right?
We have x minus 8, right? We have x minus 8 here and we took minus outside here. So it will be minus x squared plus 8x, right? Minus will be cancel out. Then it will be plus. When we're taking...
No, it will be minus x minus 8, right? When we take common, it will be x plus 8.
No, we have x minus 8. So here mod is all over the like factor x minus 8. So we have to take minus or plus with the whole factor x minus 8. If it is negative, then it will be negative of x minus 8. And if it is positive, then it will be positive of x minus 8. Okay.
Okay.
So again, it's clear. Then if we take x tending to positive side of the 8, then it will be the same equation, 8 cube plus 8 square minus 8 square plus 20, right? And again, we can cancel out this two term and it will be same. So we can prove this, that limit exists for the function, right?
Yes.
And this is basically equals to f of 8. So it is continuous, right? So now what we have to do, we have to check whether it is it differentiable at 8 or not, right? So tending to 8, h tending to 0 plus f of 8 plus h minus f of 8 by h. So what will be the next step? Now h tending to 0 plus, that means h plus 8 will tending to 8 plus, right?
Yes, ma'am.
That means we will take this function, right?
First one.
First.
Yes, ma'am.
Yeah. So it is x cube plus x minus h. Sorry, we have to put it will be 8 plus h cube plus 8 plus h into 8 plus h minus 8. That means it will be h again, right? Then
Yes, ma'am.
minus 20. Or probably it was plus 20, I don't remember.
Plus 20, ma'am.
Yeah, plus 20. And what is the value at f equals to 8? It was
532.
532 by h, right? So what will be the limiting value? You can now easily calculate it, right?
Yes, ma'am.
What is the limiting value? Any one of you, can you say what is the limiting value? We can break this function, right? H
Yes,
cube
ma'am.
plus 3 into 8 into h square plus 3 into 8 square into h plus 8 cube, right? Plus
Yes, ma'am.
8h plus h square plus this term minus 512 by h. Now what we can do? What is 8 cube?
512.
512, right?
Yes, ma'am.
This two term will be cancelled out, right?
Yes, ma'am.
Yes, ma'am. You should take h as common answer, I think.
Yeah, we can take 8 as common, then it will be 8 square plus 3 into 8 with
And use the L
3.
hospital rule now, no? It will be easy, right?
No, because here we don't have this indeterminate form. We can cancel 8.
Use 0 by 0 form.
And 0 by 0 form is there, na?
But we can cancel out 8, right? So why will
Okay.
we
With that.
like apply this L hospital rule? Okay.
Yes, ma'am.
So if we put directly 0, then it will be 8 plus 3 into h square, right?
Yes, ma'am.
192 plus 8, 200.
200. Okay,
Yes.
so what is the other limit? What is the other side? What is the other side? It will be 8 plus h cube minus 8 plus h into h plus 20 minus 532 by h, right?
Yes, ma'am.
So similarly, we can simplify it and calculate it, right? So what will be the final answer?
Ma'am, the denominator should be minus h, right?
No, we are taking h from the negative side of 0 here. So here we don't need to put this as minus h. Okay. Okay.
Can I give a tip?
So what is the answer?
Yeah.
What is the answer? It will be similar, right? 3 into 8 square h plus 3 8h square minus 8h minus h square by h, right? So 3h square minus 8. Here we have plus 8. For this case, we have minus 8. Okay, so these are not equal.
So they are not differentiable.
Yeah. Fine.
The graph seems to be fine.
Can I give a tip?
Yeah, sure.
Yes.
Just you got to scroll up.
Here?
Little more.
Okay.
Yeah, here. We have two equations for the function as it approaches left side or right side, right?
Yes, yes.
Since all the students know how to find the slope, basically you take the derivative of that, it will be easier. Derivative of the first function.
Yeah.
That will give you the slope at the left side. This is the right side. If they are not equal, it is not differentiable.
Yes.
No.
So these are the easy step verification. So here we are just following the like definition.
I'm not commenting on that. This is a fundamental every student should know.
Yeah.
But on a day-to-day basis, you don't have to keep counting everything. You know, you can multiply when it is required, when you can take a rule.
Ma'am.
Obviously. So while seeing this mod function instantly, we can comment over the differentiability. Okay.
Yes.
So I don't think there is any need to calculate it even. But yeah, if you want to like practice the traditional method to find the whether the function
nothing
is
wrong,
differentiable or not, then we
But
can
they
do
should
it.
not get demotivated. I got to do so much work. So that is why I said this tips. This they should understand. These are two different equations.
Yeah.
So the slopes will be different, and when they are different, obviously it is not differential.
Yes. Obviously, these are also correct. No problem.
Yes,
Ma'am,
it's
so
an easy
basically,
one.
we differentiate both the equations, and if the slopes
Yes.
are equal, that is the first order derivatives are equal, then it is differentiable. Otherwise, it's not. That's the basic thing.
Otherwise, it's not. Yeah. Here we are doing the same thing. Here we are doing the different, and here we are also differentiating this equation with the traditional definition. But you have the formula.
Fundamental by counting every beats and by bytes.
Yeah. The traditional definition, we're doing that. But if you already have the formula, you can apply it. Like the formula is only based on the traditional definition. So these are basically same.
Yes.
If there is time constant, then why you don't need to do the whole process.
That becomes easier now, ma'am. MCQ type, and then there is time, so this becomes
The
easier.
reason why I said is I didn't want students to get discouraged, feel that it is too tough, and then run away from mathematics.
No, sure. It's really good to point it out. But yeah, basically both the things are same. Okay. So if you have the formula, shortcut formula, and you don't have that much time, so obviously it's better to apply those formula. So if the function is differentiable at that point, then for both the function, this one and this one, the derivative will be same at the point 8. Okay. So for this, to evaluate this one, you can also apply the formula, which we know is a pretty simple formula. Okay.
Ma'am.
Yes.
For the left-hand derivative in the formula, when do we take the minus h? Like,
because here we're taking h tending to 0 from the negative side.
okay,
Here
so
we
for
are
that,
taking
the formula would be f of a minus h
because
minus f of a by minus h, right?
yes. So if it is not the case, then if we are taking this h tending to 0 from the negative side or from the positive side, so based on this condition, we're taking a different function, right?
Just
We're
like we
taking two
do
different
for
functions.
continuity, right?
Yes.
Okay.
Same concept which we already did in limit and continuity. Here we are doing it similarly. Okay.
Understood, ma'am. Okay, thank you.
Fine. Okay. So one more example I have in my mind. So this is the given function. You know the fraction part? You know the definition of this function within curly bracket? This is again our box function, which is like f of 2.5 is 2, that we know. And this fraction part is basically fraction part of 2.5 is the fraction part. Okay. And for integer, it's
your box is a ceiling. Sorry, floor.
Yes.
Floor.
No.
Floor
It's
function, right?
Yeah. This
Is it a
box
floor?
function is basically a floor function. So you know the floor function, right? You know the definition of the floor function, right? So
Yes,
I don't
ma'am.
need to explain it. And this function, it's just the
residual part.
After the point. Okay.
Residual part.
Integer, this portion will be 0. Okay. The value of the function is 0 for the integer point. Okay.
Yes, ma'am.
Okay, ma'am.
So this is the definition. Now you have this.
Wait a minute. What did you call that function name?
Fractional part of x.
Sorry, x plus 2 within some curly bracket, whatever you put.
Fractional part of x plus 2.
Maximum?
Fractional part.
So it will always be 0 to 1.
Yeah.
Yes.
That's a
Actually,
residual.
x minus floor function.
It's a mod 1, right?
Yeah.
Mod
It's
1.
always varies from 0 to 1.
Yeah, it can't be more than 1.
This is a fractional part of some point. Okay. So when the point is integer, obviously the fractional part is 0, right? And when it is a function, then it will be something like that. So it's always from 0 to 1. So the definition is now clear, right?
Yeah.
Yeah. So the question is, first let us consider the limit. Whether the limit exists at the point 0 or not. Limit. What do you think? At the point 0, limit exists or not? Here again, we have to consider the left-hand limit and right-hand limit, right?
Yes, ma'am.
Yeah. So try to solve it. What will be if there is the limit, then what will be the limit? Or else if like you have to do the comment over the limit, whether the limit exists or not. So what will be 0, 10 extending to extending to 0 from the negative side, fx.
Minus 1, right?
Try to think it. Is it really minus 1?
2.
No, it is 1.
What will be the final answer? What do you think? What should I take?
1.
Okay. So when 0, suppose this is our 0, okay? So x is tending to 0 from the negative side, okay? That means from this side. X is tending to 0 from the negative side. That means x plus 2 will be tending to 2 from the negative side, right?
Yes, ma'am.
That means it will be in the interval
1 to 2.
1 to
right?
1 to 2.
So this will be 1, right?
Yeah, okay.
And what is extending to 0 plus fx? Then we will take this function, right? Because of this interval value, right?
So we need, because you said x equal to 0, it is 0. There itself is a discontinuity.
Yes. At x equals to 0, like that means f of 0 equals to 0. We have the value here.
Yeah, since the value is given, I don't have to even worry about all this.
Why?
It is discontinued.
No, it may be discontinuous, right?
It is discontinuous.
Okay, yeah. Basically, but what about the limit? It is discontinuous because 1 is not equals to 0.
That's what I'm saying. Left side we found out
But,
it is approaching 1 and value
Mhm.
is 0. There is a discontinuity. Why should we worry about the right side whether it is approaching or not?
No, it's fine. This function is discontinuous. But what about the limit? I'm talking about limit. If the function is discontinuous, still there is a chance for the limit to exist, right?
Even right limit. Yeah.
So what about the limit? What is the limit?
Limit does not exist.
So what will be the positive side? What is the right hand limit?
And then it will
What is
tend to
the value of
0.11111, nearly to 0 itself.
So x is tending to 0, right? From the positive side. That means x plus 2 tending to 0 from the positive side, right? Sorry, 2 from the positive side. So this fractional part will be tending to 0, right?
Correct.
Yes.
So both the left hand limit and right hand limit are not equal. So limit doesn't exist, right?
Yes, ma'am.
Can you explain the right hand limit again, ma'am?
Yes, ma'am.
Okay. So here we are taking x tending to 0 from the positive side. That means x plus 2 will be tending to 0 from the positive, tending to 2 from the positive side, right?
Yes, ma'am.
Yes, ma'am.
That means suppose we have this graph that 2 to 3. So this x plus 2 will be tending to 2 from this side, right?
Yes, ma'am.
Yes,
Then
ma'am.
the fractional part will be tending to 0, right? Because suppose we have 2.5 here, 2.5. Then if we tend to this side, then it will be 2.75, sorry, 0.5. Then again, we can put here, there is a point 2.005. So this part is gradually tending to 0, right?
Yes, ma'am.
Yeah. So when we are tending to some integer number from the positive side, for the fractional function, the fractional part will be tending to 0, right?
Yes, ma'am.
Yeah.
But the answer
So,
is slightly greater than 0.
yeah,
I am right?
it is greater than 0, but the fractional part, it will be tending to 0 from the positive side.
Positive
Okay.
side. Yes.
Yeah. So it's clear?
Yes, ma'am.
Yeah.
Yes.
So limit doesn't exist. What if we change the function x as x plus 1? Then what will be the case?
At x equal to 0 only, ma'am.
Yeah.
Limit is exist.
Then the left
Limit
side part
takes
becomes 0.
0. Left side
Function
will
is
become
there.
0.
Yes, ma'am.
Then it will
Function is
become 0, right?
Yes.
Yes, ma'am.
So then limit will exist and the function will also be continuous at that point, right?
yes.
Yes.
But function is not differentiable.
Okay. We will talk about differentiability later. Okay. Can you find the number of point for this function x plus 2? The number of point at which the function is not continuous in this interval, -4 to 4. Point.
Number of discontinuous points.
Yes.
Good. Very good.
Number of discontinuous point of discontinuity in this interval.
Whenever it will not be an integer.
It is for fractional
No.
part, isn't it?
Is it always the case?
No.
Because we have this thing. We know that step function is not continuous, or limit doesn't exist, because we know that the left hand limit and right hand limit are not equal in general, right? But here we only have we have to consider one side of the limit for this point, -4, right? We don't need to consider the left hand limit. We only need to consider the right hand limit for this point, -4. So -4 is an integer point, but in this interval, this point is not a point of discontinuity of the
I
function,
don't
right?
understand, ma'am. I don't
Okay.
understand.
Okay. So the function, we fix the domain -4 + 4 for the function f, right? F is from this domain to real number, suppose. Okay. So now we need to check continuity at the point -4. Is it continuous at -4 or not? What do you think?
Not continuous.
Why?
Because the function reason is end at -4. I think.
The left side would not be 0 and right
Ma'am,
side
it
would
should
be
be
0.
continuous now, because one side does not exist and the other side exists, and
Yes.
at that point also the value exists, so it should be
Here
continuous.
we will not consider the case extends to -4 from the negative side fx, because we don't have this region in our domain, right?
Yes.
We
Sir.
don't have this region in our domain.
One
So
point.
this case we will not consider. We will only consider this case extends to -4 plus fx. If it is equals to f of -4, then the function will be continuous, otherwise not. Okay.
Ma'am, I didn't understand why we are not taking -4 minus case, ma'am.
This term we are not taking because our domain has started from -4 only.
So it doesn't
We
go
don't
away
have
from
the
-4, it
negative
is only tending towards -4 plus. So we are only considering this
Yes.
-4 plus region.
We will consider this approach only. Okay.
Yes, we can approach only from the right hand side.
Because this approach is not in our hand now. Because this is outside our domain of the function. Okay.
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 So it is equal, right?
Yes.
So this point it will be -4 plus 2. That means it will be -2 for both the cases, right? So
Yes, ma'am.
-4 is at -4, the function is continuous, right? But what about -3? We can then
Discontinuous.
do the normal process, the positive side and negative side for the point -3, right?
Yes, ma'am.
And what about -2?
Discontinuous.
Similarly.
Yes.
And -1.
Yes.
Okay. Now we already have 0 is again a point of discontinuity, right? So we got 4 point of discontinuity. Now what about this portion from 0 to 4? What
1, 2,
about
and 3. 1, 2, and 3 points are
at the
discontinuous.
point 1? At 1.
Yes.
At
1,
1.
2, and
X equals to 1. Whether the function is continuous or not.
not.
Why?
Because the fraction part is discontinuous the graph.
Okay. So we can do this. We can take from the positive and as well as the negative side of this one, right? If we take this function, so what this will be limit extending to 1 minus, that means we're taking this approach now. X plus 2, right? So extending to 1 from the negative side, that means x plus 2 tending to 3 from the negative side, right? That means this fractional part will be 1, right?
tending to negative side.
The
How one,
limit is
ma'am?
1. The limit is 1, right?
Yes.
Limit is 1.
Right?
The right side will be 0.
Because we are tending this way. And the right side limit will be, what will be the right side limit?
0.
Yes. The right side limit is 0. So
Yes.
basically these are not equal, right?
Right.
And this is equals to f of 1. So similarly, for the point 2 and 3, we can conclude the same, right?
Yes.
This is a
What
very
about
good
the
example.
point 4?
This is a very good example for people to understand the limits.
Yes. What about the point 4?
This is
It will be continuous
continuous.
because we won't
Continuous
have the
or
idea of the
discontinuous?
right hand side.
Yes, continuous.
Yeah, we'll only consider the
But this
Left
will
hand
left
be
hand
side.
a
side.
trap for you again. Think about it properly. There is again chance to be discontinuous. If
Exact 4 is the 0. When
4
we
minus
4
f
minus we won't
not
consider, no,
equals
ma'am.
to f4. If this happens, then it will be discontinuous. Still there is a
because,
chance to be discontinuous.
because the exact 4 put exact 4 number and then
No,
fx
4
is
minus we'll consider, 4 plus we won't consider, no, ma'am.
Yes, yes. Only we will consider 4 minus this.
Because again, that is out of our domain.
Yeah. So limit exists, but what about continuity? Still there is a chance that the function may not be continuous, right? Because of this condition, right?
It is not continuous.
Yes. Then it will be 1, right? But this is not equals to f of 4, which is
0.
0.
clear?
yes.
So it's not always the case that like we have only one hand limit. That means the function is continuous. We cannot draw the conclusion directly, okay? Even for limit, we cannot draw the conclusion directly, okay?
Ma'am, if we consider this as x minus box of x plus 2, then it would be easier because you already have the value of box.
Yeah.
Ma'am,
But we need to study this function. We needed to study this function. That's why I did it. Yes.
ma'am, at point 1, can you please explain it again, ma'am? The fractional part, ma'am.
Point 1.
Yeah.
This one?
Above that, ma'am.
This one?
Ma'am, where the answer you got as 1.
This one.
Yeah, ma'am.
Okay. So here this is our line, right? 1, 2, 3. So we're tending to 1 from the negative side, right? That means we're taking this approach for x. Then
Yeah.
x plus 2 will be tending to 3 from the negative side, right?
Okay, ma'am.
That means here we have 2.5. Then it will be some 2.75. Then here the point will be some 2. Something near to 1, right?
Mm-hmm.
Like 9900 something, right?
Yes, ma'am.
Right?
Yes, ma'am.
Okay. Just give me 1 minute. Oh, 4. This is not tending to 1. This is actually
Ma'am, fractional part, can it be 1 ever?
no. Wait.
Approximately 1, I think so.
0.99 something.
Yes, this is like some.
Approximately 1.
It will never be 1.
Limit won't exist,
Yeah.
so it will
That's
tend
the
to
this
that.
limit is basically 1. Sorry. I got confused suddenly. So the limit is basically 1 because it will tending to some 0.09999. Just it can be some infinite time of 9. Okay. Okay,
Yes.
the actual number is some 0 point infinite time, like number of time 9, but the limit will be then 1, right? Is
We
it
assume it to
easy?
be 1.
Yeah,
That is a definition of limit.
limit. Yeah.
Limit
That
is
is the
something you
definition of
never reach, but you aim
Yeah.
and go towards.
Yes. Limit is basically the limit. It's the upper limit.
Okay, ma'am, got your point.
Yeah, this is not the value directly, but at some infinite point, we may be near to that point. Okay.
Yes, ma'am.
This is how this point become 1. So is the problem clear?
Yeah, ma'am, got it.
Yeah, if you have any doubt with this problem, you can ask. This is a very good example, so you can like note it properly, note it down properly. Okay.
Can I make a comment?
Yeah, sure.
It's a wonderful example.
Mhm.
I think all the youngsters should understand the concept of limits.
Yes.
You could probably give them a simple exercise to figure out floor function, fractional function, step functions, mod,
Sure.
how the limits are derived and discontinuities are discovered.
Yes.
Let them play around, and then, I mean, not just for the course. Course is
Yeah,
the aim.
you
Course is
need
only
to understand the concept properly.
yeah.
Yes.
I mean, course is only a step to make a better life.
Yes.
In my experience, I have found out many of the students today, whoever is listening, they don't know why we are doing a linear approximation for a point.
Yes.
Because the teacher asks, they do it.
Mm.
If the function is complex, for a nearby value, it will be too complicated to figure it out, so we make it linear approximation.
Yes.
The purpose of finding the linear approximation is not known. And they just do it just because mechanical. Okay, teacher asked, quiz me, I have a question, I have to do it. Later in the life, they forget. They can use the linear approximation when the question comes. Okay, this is a complex function, I can do a linear approximation to figure out. I don't know. I mean, this is from my experience, I'm giving you input, so you guys can probably use it.
Yeah. This is
Every formula, every methodology being taught has got a purpose to help us in improving our life situations.
Yes.
Thank you.
Okay.
Can you please give some more questions for us to practice on our own, ma'am?
Yeah, sure. You can do a question in this pattern also, like changing these values and all. Wait. Also, you can take like you can observe the function with like taking some open interval instead of closed interval. Okay, so you can take some a disjoint interval also. Suppose for the same function. Suppose this is the example. You can do it on your own. From suppose from -5 to 0 over this interval. Okay, at x equals to 0, and suppose we are taking the same type of example over some from 3. This is 3. Okay, 3 to 5. Suppose this is our function. Then try to solve. Try to make the comments same comments, whether the limit exists at 0, the number of point of discontinuity. Okay, this is a similar type of question. You can try to solve it. So here the domain is a discrete domain, right? Like not discrete, this is a discontinuous domain, right? Right? What is the domain here? -5, 0, union 3, 5, right? So you have to check the continuity over this domain instead of a continuous open closed interval. Okay.
Yes, ma'am.
So this is one example. In my mind, you can solve it.
Ma'am,
Yes.
one question regarding the discontinuity of a composite function. When, like, can we say that if either of the functions, let's say G circle F is a like if we want to find if it is a discontinuous function or not, if it is like if either of the functions is discontinuous, is the whole function discontinuous, or we have to check for both?
Can you repeat it? What is your actual question?
Ma'am, let's say there is a composite function.
Acha.
G circle F. And if we want to find the discontinuity of the function, is it necessary if like is it okay like if it is discontinuous at one point, does it mean the entire composite function is discontinuous?
If suppose like F is
discontinuous, f of x is discontinuous, let's say,
at x equals to some a.
Then is it that G circle F is also discontinuous?
Not necessarily always.
Not necessarily. Okay.
Yeah. We can find some examples such that maybe F is not
Continuity is
discontinuous.
defined only with respect to a domain point.
Yes.
Always we say it is
So we
continuous in
cannot
a range.
directly comment over that. Yes.
No, it is continuous in a range except these points or except this range.
So yes. So someone was asking something else, I think.
Ma'am, when we say G of F is, let's say, we don't know whether it will be continuous or discontinuous, but we exactly know that for x is equal to a, f is not having a value. So isn't it
for x equals to a?
Because it's not part of domain.
Is not defined, right?
Because it's not in the domain. A is not in the domain.
Then definitely A is not in the domain of G compose F.
Yes, ma'am. That's what I was asking.
Yeah. Then we will not consider the point because for the continuity, the point must be in the domain. The point must be a point from the domain. But for the limit, we don't need the point to be in domain.
Yes, ma'am.
For continuity, we need the point to be in the domain.
Yeah, ma'am.
So again, we can suggest what I just suggested, this book SK Mappa. This is basically a very basic book for introduction to real analysis. You can find it. It is available over the internet. So there are lots of examples for limit, continuity, sequence and all. You can take this book and solve all the example. Okay. Then the concept will be more clear to you. Okay.
Oh,
This is very
Solve that activity 8, week 8 activity 3 question.
Okay, so you have doubt with some question, right? Which one?
Pasted in the chat.
Last one, I can see one question. If x plus 1 equals to if x, if y, and we have f of 9 equals to 6, f dash 0 equals to 4. So f dash 9 equals to what? This is what we have to find, right?
Yeah.
Okay. So what is f dash x plus y? This is f dash x
into f dash y.
fy plus fx.
Into f
Okay, this
dash
is a
y.
two variable function. Sorry, this is a two variable function.
Can I
Yes.
can I confuse everybody? Which I have been doing all the time. Is y related to x or is it independent variable? The question doesn't say whether y is related to x or not.
Yes.
They're two independent variables, I guess.
Are they independent? Are they dependent?
What do you think?
Independent.
Independent, like statistics approach. If you use.
F of x plus y is equal to f of x into f of y can be satisfied only for exponential functions.
Yes.
If f of x is e power x, then that is true. There is no other function in
A
the
to the power x. A to the power x.
e power kx or whatever it is.
That's exponential only.
That is the only explanation. If I use that, the initial parameters, what they give, doesn't match. So this, of course, the purpose in this.
But in this case, is it possible to find y in term of x or x in terms of y? Is it possible to find?
All depends. Look, if f of
No,
x plus
in this
y,
case, is it possible to find y in terms of x?
no,
Suppose later take this.
no, they could be entirely independent.
Why? So is it possible? It's not possible to find y in terms of x, right?
No.
Yes, it's not
So
possible.
from this,
They're independent. They can be
also, what I'm saying that from this we can also comment on the like dependency or independence of the
How
function.
many students will know f of x plus y, fx plus fy results only, we are talking about a power a. I mean, that's to that extent, if these guys at the level of foundation, don't expect them.
Yeah, this fine.
So anyway,
So
what I'm saying, if the questionnaire has specifically said y independent of x, then the answer would be different. Then we can expect the students to learn how do we handle it. If they say it is dependent, then the dependency must be defined. In the absence, it becomes a complex.
Yes.
But if we are differentiating two independent variables, then that becomes a completely different thing, right?
Yeah.
You get into partial
Yes.
differentiation. And
That's
all.
okay.
Yes, then we
You
have
don't
to
have to
do
use the
partial
term, but at least they know that is dependent, there is a variation. Maybe that is a one way of teaching them the partial, all those things. But suddenly you don't put x plus y. They could have put x plus a. Then it is not a problem. At least everybody knows a is not it's a parameter, it is not a variable. Here when they put x plus y, most of us, we believe x is a variable, y is also a variable. But are they dependent or independent? So when you take the differentiation, then I got to take care of dy by dx.
Yes.
You go ahead and then see what are the
In
complications.
this case, y is the dependent variable.
We can assume that, and we can also assume that it is not dependent. Then you go through all the stochastic or whatever.
Y must be the dependent variable over x, right? Otherwise, how could we differentiate it?
We are talking about dependence. If I say y is dependent, it depends on y, x. Otherwise, it doesn't. Then it is independent.
Yes.
We are talking about dy dx, whether it is something or is it zero. that changes the scenario.
Yes. So,
Give this feedback.
it's always not necessarily like what I think. If we have some condition like that, this need not be necessarily for a particular example. There may be various examples. We don't know, right?
I know. That's why I said that no, this is perfectly all right for exponential. This is perfectly all right for exponential. If I use exponential, the initial the conditions contradict.
Okay. Yes.
You please work it out and then you will see the numbers they are given. F dash 0 and then F1. It contradicts. So this is a very hypothetical.
This example, f of x equals to exponential. That is what
it has to k power x. Take it as a k power x.
K power x. Okay.
No. A power kx. Sorry.
Okay. A power kx. Okay. Then this equation become a power kx.
No, you put it wrong. Sorry.
What is your
e power kx? Sorry, e power kx.
E power kx.
Yeah. Take f of x is equal to e power kx. Then whatever is the condition given, f of s is equal to, which is f of x and f of y. Correct?
Yes.
This is the only condition where this will work. So now we know f of x is equal to e power kx. Now differentiate, it is k e power kx. Now substitute the values for a k, x is equal to 0 and 1, you find a contradiction.
That means k equals to 4.
4. F of 1? F of 1
So
is given. No, they give f of 1, right?
F dash 0 equals to 4, right?
Okay, F9 is given 6. Substitute
Yes.
F9. 6 is not.
E power k.
It doesn't. K is to be 4. Yeah. It's not e power 36.
Yes.
It comes as something like 0.19. Okay.
Here
we have to
we
take
have
log both side.
No. What I'm saying is initial conditions given cannot be satisfied for this.
No. See. These are the initial conditions given here, right? That means we need to choose the function such a way such that these two conditions, like the function satisfy these two conditions.
Correct. Give me a function which will satisfy.
Is not satisfying this condition. That means we cannot take this example for this function f.
Then give me a function which will satisfy where f of x plus y is equal to f of x and f of y.
Sir, it can be.
Wait a minute. I will challenge. It doesn't exist. It doesn't exist.
Okay.
Because you make one of them 0.
Simply x equals to y because x and y both are independent variable. So it will become f of 2x equals to x squared, right? Right? We can do this. F of 2x into 2 equals to 2fx. Right?
I leave it to you. You can figure it out. Discuss with your colleagues. Get back to me if there is a question.
Ma'am, see the
But
same
when-
question exists in mock test also, mock quiz also.
It is there. It is there.
But how can we consider, like, on what basis are you considering X to be Y? You're just considering it.
Okay. So X and Y both are independent variable, right? So what I think, if both are independent variable, we can take them as same.
But like why? Like,
Because otherwise it would be like a partial differentiation question if we have it as independent.
but we are already saying that it is independent, right?
Where did they say?
No. For now, we are saying that they're two independent variables,
We
right?
are assuming that instead of Y, we make it as a A.
Oh.
Let's go ahead. No problem. Nobody wants to differentiate a A.
Okay.
Hello, ma'am. Can you summarize what the whole question is? It's just so confused. What the main point of the question?
This is the main question. This is the main point. Nothing. We have this function such that this function satisfies these two conditions, these two initial condition. Then we need to find the value for f dash I.
Hello,
So
ma'am.
So,
Can I say
the
something?
function here written
for
fx plus y is equals to fx plus y. This simply represent the function a to the power x, and then we can substitute the values.
If we simply take the function as e power some kx, then we can see that this is not satisfying this two condition. Okay.
Ma'am,
That
a to
means
the power x.
some a to the power x.
Yes,
Yeah.
ma'am.
No, like in the earlier we have this we're discussing about this particular example. This fx equals to e power some kx. So you can see that this function is not satisfying these two initial conditions. So from this we can say that this is not example for this particular function. Okay. Now if
Okay,
you
ma'am.
want to this conclusion you have made up to now. Now, if we like want to take some a power kx, this is also possible case. So if we just do the derivative, so it will be again k a power kx. We don't know what is the k. So here we have this condition. So f dash 0 equals to 4. This is equals to k, right? That means k equals to 4. And f of 9 equals to 6. So a of k power 9 equals to 6. So a power
36
equals to 6. That means this will imply 36. Sorry.
We'll take log, right?
Yeah, we can take log, then it will be 36 will be some log of a base 6. This is of a base 6. Then this will be 1, right? So it will be 36 equals to some log a base 6. So there may be some value of for this a. Obviously, solving this, I don't think there is any solution for this because
There is no difference.
yeah, there is no difference actually. If we take a
A power
instead of
kx
b,
is A power kx will be equivalent to e power kx with different a.
yes.
It's all it'll leave this aside. Let's
So
go ahead.
it's again same.
Let's
If
go ahead
you
with
have an
whatever we
integer
can.
value and the sum power, you cannot take this. Okay. So there is no solution.
But you know what, ma'am? So in the activity, the answer was given as 24.
Ma'am,
the
actually,
thing is, that means this type of example we cannot consider here. That conclusion we can made only, okay? From this, that means this kind of example, this A is any real number. We cannot take this type of example for this problem.
Yes.
Because
we cannot use
cannot
any
find
known functions. We have to
Hmm.
use something imaginary and believe
Yes.
boundary conditions are met and then leave the logic behind.
Yes. So basically, we cannot use this function because this is not satisfying this condition.
Ma'am, can I say something? Ma'am, as per the question, it suggests that for values of x plus y, it's equal to function x into function y. What if we directly substitute x equals to 9 and y equals to 0? From that, we can get that function at 0 is equals to 1. And then we can directly differentiate by using the chain rule.
Chain rule we can't use because they are multiplied, not function of
Yes.
each other.
Yeah, but
chain rule
function
for,
derivative into
composition
function plus second function derivative into function exists now in chain rule of multiplication.
ma'am,
And we are assuming that both are differentiable functions because the differentiable of function at 0 is arc. So that's why we can assume no that both are differentiable. By that way only we can conclude that the
of f of y.
function of 9 is 24.
Not getting your point. What are you saying? So can you say it properly one by one? So I can at least get it.
ma'am, actually, are we trying to find that particular function which satisfies this equation, or we are trying to just solve?
No. We're trying to just solve it, but we
Ma'am,
got that.
ma'am, to solve, we don't need all these things, ma'am. We don't need a function.
Yeah, obviously we
Listen,
don't need a function to
getting
solve
the
it.
result is not important. To understand how the functions behave is important for us.
Because yes,
That is
we are
important.
analyzing the behavior of some known function which satisfies this condition. Okay, it's not necessarily to solve the problem, but we are just analyzing the behavior of this function. That's why we discuss this.
Can I give a suggestion? Let us assume that y is replaced by a capital A.
Why?
In the
Capital
problem,
A.
if just let us replace it. If somebody
What
gives
is
me a
capital
problem,
A?
f of x plus capital A is equal to f of x plus capital F of A, then A is a constant.
So f of x plus capital A.
Yeah, if the problem was described like this, then there is a very easy, the logical solution, scientifically satisfying our intellect.
Yes, then we will then our function. Here the function is also function of one variable, no problem. But here y became a constant, so it's became more easier. So what was your conclusion for that?
Ma'am, the one functional equation which has been given to us, there exist only two things, either fx is equal to 0 or fx is equal to a to the power x or any other exponential equation. But fx is equal to 0 is not possible because f of 9 is equal to 6. And we have tried the exponential function also, that is also not possible. So there exists no solution.
Okay, we cannot take any constant. But
If we take constant, then f dash 0 would be 1, but here we have already given it as 4.
We need to find, if we want to find the example, then we need to construct the example based on this condition and all the conditions, the initial conditions and the functional condition. here what we are doing, we're taking some example which satisfy this condition, and we're like think that it's not satisfying this initial condition. So from this we can only make the conclusion that this function doesn't satisfy this problem, this whole problem with this initial condition. But there may be some function which satisfy this like this function condition with the initial condition. For instance, if the example is not coming in our mind, that doesn't mean there is no example, right?
Ma'am, how is it possible, ma'am? Because the functional equation given to us can have only two solutions. Huh? Either fx is equals to 0 or fx is equals to a to the power x. That is the exponential equation, and we have tried both. Fx is equals to 0 is not possible because f of 9 is 6, and the exponential we have tried, it's not coming.
How do we know that we have only two solutions?
Ma'am, this is a proper well-known functional equation. Now, there are only two solutions. You check anyway. Either fx is equals to 0 or fx is equals to a to the power x.
Okay, so
I have studied this. Ma'am, can I say something?
Yes.
I have studied this also in my schools, and we assumed fx is equals to a to the power kx in general. I don't know it is correct or
No,
not.
we can assume that like if we have only this condition, then we can assume that. But we have the initial condition also. And here we can see that this example is not satisfying the initial condition, right? So for this case, we cannot take this as an example.
And it is given that x and y are independent variable.
Okay.
Ma'am, it is given that x and y are independent variable, right?
Yes.
They didn't say that.
They didn't say that, but what, like for instance, what I think we cannot
problem statement
express
doesn't
y
have
in term of x.
the problem statement does not say anything about the nature of x, nature of y.
Yes. Yes.
So how can we then evaluate
Like,
the
but
answer?
the thing is, we have this condition with x and y belongs to R, like some arbitrary real number. That means they are two different variable. That means we can assume that they are two independent variable. They are two different independent variable.
Ma'am, check the chat box once I've shared your file.
What is
Yeah, this is I have my copy and this is same functional equations which I have studied in the
okay?
preparation.
Here you have the condition for the equation,
Yeah.
but we here you don't have the initial condition, right? Like which initial condition we are using here in this particular problem.
But
So
here
in
it
this
is
case,
mentioned
we
that
don't
x
have
and
any
y are
problem.
independent variable, so that we can say fx is equals to a to the power x. It is mentioned x and y are independent variable.
See, this example satisfies this equation, but it is not satisfying this initial condition. If we don't have this particular condition, instead of this, we may have another condition, or there may be no condition, no initial condition. Then we can take this as example. Then there is no problem. But for this particular problem, this is not satisfying this initial condition. That's why we cannot take this. Like we cannot take this particular example.
Can I request you ignore that possibility? Let us see what could have been the expected methodology by the questioner, examiner. Let us have a view of that. Just forget that f of x has got anything from the power equation.
Yeah, we
Leave
can
it.
do. We can put.
Let's see how we
can
can.
take x equals to y.
What is that? X
What-
equal to y.
What is coming in mind? We can take x equals to y.
Why?
just two, we have two different variable, right?
F of 2x is fx square. F square x.
Yes.
Are there any f square x? Are there any function that we know? I know linear, exponential, which is covering all sinusoidal, and transcendal.
Okay, this type of function you cannot take this. Also, yeah. So there was one possibility to
Okay.
take some constant function.
Let's forget that we need not know what is fx, right? Let us do how we approach this problem from the student's perspective. We are imagining a 12th standard student with a little background in calculus attempting to solve this, where somebody is told f of x plus y is equal to f of x and f of y. Okay? And they given an initial condition, I am supposed to figure out something. Let's, from their point of view, let us look at it, how we approach. Forget all these intellectual discussions. Erase this.
Okay,
We are here to motivate the students to love the mathematics and love the way of analysis. So I don't want to confuse them. Yes, there are a lot of what we call poles and blow up points. Later on, they will figure it out. Let's right now go ahead with this. I'm sorry. Yeah.
And
forget whatever we discussed. Let us proceed how we can solve this problem.
This was a problem, right? Let me verify once.
Yeah, that's what they asked. One of those.
So we simply take like x equals to y with 2x.
Ma'am, instead of taking x equals to y, can we just take x equals to 9 and y equals to 0?
So what you are saying, x equals to 9 and y equals to 0.
Yeah, so we will get that
Then
function.
we will get another, then we will get this condition.
No.
So f of,
no ma'am, we will get that f of 0 is equals to 1.
And then we will get another condition.
Yeah ma'am, then using this, if now when we substitute 9 and 0 in the same equation and then we will derivate it, then we can get f dash 9 equals to f dash 9 into f0 plus f dash 0 plus f9. We know f9 and f0 both. f0 is 1, f dash 0 is given 4, f9 is given 6, and then f dash 9 is what we need to find. So then we will get the answer 24.
Wait. You put x equal to 0, y equal to 0, you get f of x 0 is equal to 1.
Okay, that's fine.
Yeah.
Now just write the formula of f dash of 9, right? Like in terms of f of 9
We are
plus
putting
h.
x equals to 9 and y equals to 0, then we get f of 9 equals to f of again 9 0. That means this will be 6, this will be 6 into f of 0. Then we will get f of 0 equals to 1.
Yeah. Yeah, now just put 9 and 0 in the first equation that's given to us and then just derivate it using chain rule.
We cannot put the value then derivative. First we have to do the derivative, then only we can put the value.
So still it will be same. Now we will take function of xy's derivative, which is equals
if you first put the value, then you do the derivative. It will like if you put the value, then it will be a constant, right? Then the derivative will be 0.
Wait.
So you have to do the derivative first.
From
Then you
what
can.
From what has been defined, There is nothing wrong. You can put any value of x, any value of y, it doesn't matter. You put both of them 0, you get f of 0 is 1. But to understand the behavior, the rate of change, f dash, you need to differentiate. If you got to differentiate this function, the formula, the relation, you need to know the relation between x and y. There is where you get the complication. Because the question is asking about f dash of 9. F0 is not a problem because you put x equal to 0, y equal to 0. The other side becomes F0, F0.
It's fine, right?
Yes.
Like, this is the procedure to solve the method. We can analyze the problem. But, like,
Also the
you
f
can directly, yes.
function at x plus y will also get derivated. Yeah. Yeah, then we can direct
Right.
substitute 9 and
Then
0
we
and
can
then
put
No.
9
The
and 0,
second
then
term,
we will get our...
second term, f dash y should be multiplied by dy by dx.
Yes.
Yes, ma'am. Because even if we go with this method, at then we will get 0 equals to
Well, if
24.
we take x equals to 1, then dy by dx will be 1. That's why I didn't take this.
So then?
Here I assumed this condition. That's why I didn't take this, okay?
So x equal to y then?
Yes. So dx by dx, dy by dx will be 1.
But then f of 2x is equal to f of x into f of x.
Right? Then it's same, right?
F dash.
So then we can directly put the value here.
Yeah, ma'am. But even if you continue
it
with
will
this,
be
at
same.
then you will find that 0 is equals to 24 will come.
Then it will not satisfy.
It again
And
says
there are
that
simpler
doesn't
way to do
exist.
this question, ma'am.
What?
There is a simpler way to do this question.
Please go ahead. I'd like to know.
When you write f dash of 9, you can like the formula derivative.
Let her write f dash of 9 equal to what?
That will be equal to f of 9 plus h minus f of 9.
Limit h tending to 0, ma'am.
Wait,
Yeah.
who is this? Afrin. Okay.
Yeah.
Afrin.
Yeah, he's right. Yeah.
Afrin, right?
Yeah.
Yeah, go ahead.
And then like in the question it is given when we can split f of 9 plus h minus f of 9. We can take we can write f of 9, that's the right term,
Yes.
as f of 9 plus 0.
So we have f of 9 equals to 6.
Wait. Let's follow. What is this?
This is what you mean, right?
Now, ma'am, we can write 1 as f of 0 and h as h plus 0. F of h plus 0 minus f of 0.
0 by 0 term, no?
No, ma'am. Just write f of, instead of h, f of h, you write just f of h plus 0 minus f of 0.
No, I was saying something else.
Okay, I got your point.
Wait.
F of h plus 0 minus
f of 0.
Because 1 equals to f of 0.
Yes, ma'am.
So by
h into 6.
So it will become f dash.
Ma'am, you forgot 6.
Yeah. 6. It will become f dash 0 into 6, right?
Yes, ma'am.
0 into 6, yeah. Yeah, this is probably the best way to do the
Yes, ma'am. Then we don't even need to know the interdependency of
Yes,
x and y. We
Yes.
need not comment on that as well.
Ma'am, once could you show the conditions?
forgot about this part. This was not part.
Good. F
Yeah.
dash of
So this
9.
is the question and this is the answer. Yeah, this is the best way to solve this problem actually.
It's a
It
very
really came to
localized.
my mind. Yes.
Wait, no, just show me the screen a little bit.
Yeah.
Dash 9 is 9 plus h. Okay, understood.
Fine.
Acha, F9 is given as 6. Who came with this? Afraid?
Yes, sir.
Good.
Sir, I, along with some other person, was also speaking. I think he also reached the same conclusion.
That's okay. Be in touch with me.
Okay.
I like to see you more often. This is one way of solving a crisis.
Yes.
I know the way the problem given was not expected from IIT, but you can cover up.
You can think about this example later. There is definitely some example which we have to like find, but it's not coming to my mind. But yeah.
Ma'am, there is hello, ma'am. Ma'am, there is a problem with this question, ma'am. The thing is, now that we know the concept of linear approximation, the first tendency is to go with that approach, and it yields in a wrong answer. But if you go by the normal derivative approach, it yields right answer. So, ma'am, that's the only
That means
confusing
what
part.
you wanted to do, like f of x equals to, you wanted to do this definition.
Yes, ma'am. Because after knowing linear approximation, I tried using this, but the answer is coming out to be totally different.
Because like we know only the value for this one, right?
Yes,
Also,
ma'am.
f of 0 equals to 1. So f of 0 equals to dash 1 minus 9 plus 6.
So what is the final answer here? F dash 9 is supposed to be?
It's coming out to be minus 5 by 9. Sorry, 5 by 9. Sorry.
Ma'am, how did we get this f0 equals to 1?
F of 0 equals to 1 from this equation. Like put x equals to 9 and 1 equals to 0. Then it will
That
become,
means we can put any value of x and y in this equation.
yeah, if it is in the domain, then it will satisfy the condition, right?
No, f of 0 is equals to 1. So
Ma'am, then
how we
why did we
calculate it?
have to go through this long method? We could just substitute the value in simple differentiation now.
This is fine. This is no problem. There is no problem. But there is,
I
yes.
understood the differentiability part, but f of 0 is equals to 1, how we calculated it?
Like someone just told that you can just put this and then it will satisfy for all real number, right? So if you take x equals to 9 and y equals to 0, then it will again satisfy this. This we can get. Then we will get 6 equals to 6 into some f of 0. Okay, so here, sorry, I should have checked this. Here you have two options, either f of 0 equals to 0 or 1.
No, it's always 1.
No. Oh, sorry, it's
One.
always 1. Yeah, sorry. 6 can be cancelled out.
That was independently discovered.
Sorry. Yeah.
Yeah. That was
Correct.
independent of any values.
Yes, yes. So,
Afrin had a very good insight. I need to think about it. But
Mhm.
this problem is
Because we get this,
worth
well,
investigating.
this equation should also satisfy this one. Why it's not satisfying?
It's okay. It's once in a while they also come up with some problems where they give an opportunity for us to deep dive.
No, that's fine.
Whoever is
Same
interested
question,
in
can't
go
we?
into the details, there is something more to discover. We can give an answer and then they will, we can get some mark. But
Yes, ma'am, we should move ahead, I think.
learning is to find where we are being challenged, we fail, and get up, discover why we failed. That is learning. If you keep solving all the problems, you're not learned.
Yeah,
I'm just telling to the rest of the students. Okay. So this is something we need to investigate. Whoever is interested, take it up. Personal challenge. Keep digging out. Yeah, we can give an answer and get. That's not a problem. Tomorrow anyway, they will give an answer and then they will say whether you scored or not scored. Doesn't matter. Who are there to tell us whether we are good or not? It's you. Okay?
Hello, ma'am.
Yes.
Keep digging. Thank you.
Thank you, Bhaskar. Thank you, Bhaskar, sir. Ma'am, so it means we can put any value of x and y because
yeah,
we
it should satisfy it because what is given in our question that like if we satisfy this condition for any xy belongs to real number. So if I like take any real number, for any real number, f should satisfy this condition.
so it was given in the question that it is defined for real numbers. X and y are can be any real number.
xy belongs to real number. Yeah, it was given in the question. So for arbitrary real number, if we satisfying this condition, then we can like pick some case like particular real number. Then obviously it will satisfy the equation, right? From that we can like find the value of f at that point.
Okay. Thank you.
But I think this should be also same.
Ma'am, I think because the difference between 9 and 0 is too huge, that's why it's not working out. If it would have been 9.2 or 8.8, I think that's when it would have
should
worked.
have come to my mind. Because this linear approximation around the point 9, right?
Yeah, ma'am. The difference has to be infinitesimally small, ma'am.
Yes.
Got your point, ma'am. Thank you, ma'am.
Yeah, distance like difference between 0 and 9 is like
too much, ma'am.
Yeah.
Got you, ma'am.
Okay, so what I guess we're running out of time already. So I think I cannot extend the session more. So if you have more doubt with this, I think tomorrow you have session in the morning and also in the evening, right?
I'm very sorry that I probably disturbed.
Yes,
Are you
ma'am,
going to
we
meet
have
again?
class.
Yes, it's fine. It's good to sometimes explore the mathematics. But it's the quiz time, so yeah.
Ma'am, we have a class tomorrow, 7 a.m. to 9 a.m. But
Sometimes
that's for mock paper
Also in the
discussion.
evening, you have one class, right?
But
Doubt
that
clearing
is for
session.
qualifier people, reattempt to qualifier.
I believe clarity is more important than getting some, score.
Yeah, that's fine.
At least
But
whoever is
sometimes
listening to,
it's
at least
need to
got it.
choose the priority because the time also matters. It's fine to
I know,
explore
that's
the
okay.
obviously. I will also support I also support to explore the maths.
I seen in your discussions. That's why I got involved. Otherwise, I would have kept quiet.
Thank you so much, ma'am. Thank you for your time.
Okay, so we can now end this session for today because
Surely,
it's
ma'am.
running out of time. If you have more doubt, you can ask. You can clear your doubt in like today morning session.
Thank you
Sorry,
very
tomorrow
much.
morning session also. Okay.
Sure, ma'am.
Ma'am,
Sure,
just
ma'am.
last, ma'am. Hello, ma'am.
Yes.
Ma'am, just ma'am, from week 1 to week 4, ma'am, can we expect only 1 and 2 questions, or is it possible that there will be more?
There will be approximately 3 to 4 questions, max to max. Like
Okay,
not
ma'am.
more
Okay.
than that. Maximum 3 to 4 questions.
Okay,
Can
ma'am.
you make a comment?
The more weightage will be from week 5 to 8. There will be some maximum 3 to 4 questions from week 1 to 2.
Okay, ma'am. Thank you, ma'am.
Can I make a comment?
Mhm.
I keep hearing many of the students asking for the syllabus for the quiz, right? When they graduate and
I think
life,
all of you know that the quiz syllabus is from week 1 to week 8.
Yes, actually, they have
Yes, we
sent in
had
the
an
email.
announcement.
Yes,
They
email.
mailed us.
listen, don't study these things for the sake of a qualifying, because when you qualify, come into the world, then nobody gives you a syllabus. Any of these concepts will be coming up required for you to survive. Okay? Don't look for the syllabus to. In life, we don't have a syllabus.
Mom, the same question that we were discussing for so long, I just was wondering if we could do it with assuming f of x to be exponential function.
No,
I don't
in
get
this
it.
case, f of is not the exponential function because we have seen now that it's not satisfying the initial condition. So we
Okay.
cannot take. There are some example which is not a exponential function.
Okay.
Yeah.
Thank you, ma'am. Have a good night.
Yeah. So rest of the doubt you can ask in the next session.
Ma'am,
Huh.
please share the PDF.
Mhm. PDF. Okay. Okay. I will try to share the PDF.
Thank you, ma'am.
Thank you, ma'am.
Probably I will share it in your next session. Okay.
Ma'am, tomorrow?
Yes, tomorrow morning.
Okay, ma'am. Thank you, ma'am.
Yeah.
Yeah, okay, ma'am. Thank you, ma'am.
Yes.